Let's take a look at a couple of word problems that fall under the category of projectile motion. These are some word problems that we can actually solve using the applications of parabolas that we've learned already. In this particular scenario, we have our hero, Romeo Montague, trying to win the heart of Juliet Capulet. And so he throws a bouquet of flowers up to her window. What a romantic gesture. Now, because he's also a great mathematician, Romeo realizes that the equation h of t equals negative 16t squared plus 12t plus 2 models the path of the flowers. H of t is the height in feet of the flowers after t seconds. There is a particular way that we could calculate these values, the negative 16, the 12, and the 2. It has to do with the initial height that Romeo is launching the flowers from, which would be 2 feet. The initial speed should be 12 feet per second vertically. And this actually comes from 32 divided by 2, which is the acceleration due to gravity. But that's something we'll worry more about in the future, perhaps when you get to physics. Anyways, the question is Romeo's gesture worthwhile? Do his flowers reach Juliet's window 5 feet off the ground? Not a very high balcony, but certainly he doesn't want to just chuck the flowers up as high as possible, so hopefully he gets them to a pretty decent height. And that's what we'll try to figure out right now. Well, the thing is that we could know that it would reach that height if it ever went above that height. And since this is a parabola that will open down, indicated by the negative a, it's going to have a maximum. In general, we're going to have a parabola that looks like this, and we have a max. Now, if that max is above 5 feet or even at 5 feet, we're in good shape. If that max is below 5 feet, well, then no such luck for Romeo. So what we're going to do is we're going to try to figure out the vertex of this parabola by using what we already know. So we'll start with our equation, and we'll use the formula x equals negative b over 2a. In this particular case, we're looking at negative 12 over 2 times negative 16, which is going to be a positive 12 over a positive 32. And in this particular case, I think it's going to be probably worthwhile to actually make this a decimal. And so by just doing 12 divided by 32, we get 0.375. So that means that it's actually been 0.375 seconds before the flowers reach the peak of their path. Now, to figure out what the height is at that peak, we're going to say, what is h of 0.375? And a lot of this is kind of calculator heavy here. You're just plugging in. Every time you have a t, we replace it with 0.375. And you can just use a calculator to figure out what each of these pieces is. The first one ends up being negative 2.25, and then the second piece becomes 4, and 4.5, and the third piece is a plus 2. And so that's going to combine to 4.25. That's actually going to be the maximum height if I measure that in feet. That's how long it will take. That's how high the flowers will reach. So what we'll actually see here is that Romeo's flowers won't quite reach Juliet. When he throws the flowers up, they don't quite reach her, and then they will ultimately tumble down to the ground, which is, of course, incredibly sad. So Romeo needs to bulk up a little bit in order to deliver the flowers to his fair maiden. Romeo is no quitter, so this time he alters his approach and decides that he will be throwing flowers that can be modeled by the equation h of t equals negative 16t squared plus 20t. The question is, do his flowers reach Juliet now? Once again, we're going to find the same approach. We're going to try to figure out what the value is at the vertex of both the x and the y, or in this case the t and the h, to figure out its height. So when I go to plug in to my formula x equals negative b over 2a. I have negative 20 over 2 times negative 16, which is 20 over 32. And once again, I would probably want to use a decimal approximation here. And in this case, that's 0.625 seconds. So this time, I'm not going to reach the peak of the flight until 0.625 seconds. Once again, we're just going to plug back in h of 0.625, which is going to be negative 16 times that value squared, plus 20 times that value. It's a little crowded, but you can see what's happening there. And when we plug in, we end up getting, using a calculator, negative 6.25 plus 12.5, which gives us a height of 6.25. And 6.25 feet is the maximum height that these flowers are going to reach. So what that means is that Romeo will throw the flowers up, they will go above Juliet's balcony, and then come back and land gracefully in her arms, convincing her that she should change her life forever to be with him. This is the general idea that's happening here. What we could also do is we could figure out if Juliet happened to miss them, how long this would be in the air, and it has to do, in that case, with setting or looking at the symmetry of the parabola. We know that it's going to take 0.625 seconds for the parabola to go up to its vertex. That's how long it takes the flowers to reach their peak. So if we doubled that, we would get the entire flight. This is the idea. It can be applied using the factoring methods we've done before, and also some of these vertex methods. So I hope this helps make sense, and also reminds you of the beauty of a good love story.